Welcome to Facilitating Discourse in the Math Classroom, strategies for facilitating academic discourse during math lessons. During our session, we will define math discourse, discuss the instructor's role in effective and meaningful academic discourse, and engage in reflection.
We value your time and appreciate your active participation during this module. Here are a few suggested learning norms to make the most of your time. If possible, work in an environment with as few distractions as possible so you can engage and reflect, take notes and jot down ideas and questions as needed, and lastly, use this time wisely to ensure your professional learning with university instructors is productive.
By the end of this module, participants will be able to identify the elements of academic discourse, understand strategies for facilitating effective and meaningful academic discourse in math class, and apply understanding of academic discourse to create and facilitate meaningful discourse opportunities in the math classroom. Before we dive into this module's topic, let's engage in some virtual discourse about the curious son. The curious son asks his father about the stars in the sky. Pointing to the celestial bodies, the father says, "They look much closer than they really are, but they are so far away." To this, the son asks, "How far away are they?" How would you answer the question, "How far away are they?" And what explanation would you give? Well, you might say something like, "Hundreds, thousands, millions of miles away. The distance of the stars has been measured by mathematicians and scientists using super fancy telescopes and other tools." Or you might say something like, "We can measure a lot of things with a ruler, but we can't measure how far the stars are with a ruler or any other common tool. Even if we fly in a plane, we still would not be close to them." Or you might say, "If you stacked 1,000,000 cars on top of each other, that would still not reach the stars. Even the distance between each star is light years away." You could continue the conversation, and by the end, you would learn more about how to think through the question of how far away stars are from our current position on Earth. You could talk about how some ideas are more reasonable than others, and how facts, knowledge, and understanding can justify the more reasonable responses. You would likely use language related to science, math, and even astronomy. In all, you'd end up critically thinking through processes that lead you closer to the answer. Facilitating discourse in math class is similar. Students have a chance to grapple with mathematical concepts, use academic language, and make connections to prior knowledge to solve new or more challenging math problems. But what is math discourse? The ability to facilitate academic discourse in math classrooms is only as effective as the facilitator's ability to recognize what elements actually constitute math discourse. Sometimes parsing out what concepts are versus what they are not can help us more fully understand. Let's start with what academic discourse is not. Instructor-dominated conversation is not academic discourse. During true academic discourse, students lead the bulk of the conversation. As tempting as it is to intervene and offer feedback in the way of prompting, redirecting, reviewing, or explaining, instructors must control the urge to jump in and take over. Dominating the conversation will defeat the powerful academic benefits students gain by being forced to think and solve independently. Random discussion is also not academic discourse. Facilitators of academic discourse must have planned, specific outcomes before initiating discussions. Otherwise, students may end up talking about random or unrelated topics, even if they are still discussing math. Academic discourse is not assessment-based. While you, as the facilitator of academic discourse, will assess students' contributions for misconceptions, accuracy, and relevance, These discussions should not be used as a traditional grade. Tying academic discourse into a unit or lesson assessment suppresses students' ability to think and contribute freely. Academic discourse is also not disorganized or unrestricted. Though our scenario about how far away the stars are was hypothetical, there was order to the discourse. There was a specific set of questions tied to the image that would encourage discussion to remain aligned. Rote memorization of facts and figures is not academic discourse. Academic discourse in math is not about simply shouting out math facts. Knowing that 50 divided by 2 equals 25 acknowledges memorization of that fact. However, understanding that in order to have two equal parts of 50, it must be divided by 2 takes this understanding to a conceptual level that prepares learners for an even deeper analysis of the same mathematical equation and the operation of division. Asking questions such as, who would like to volunteer to present their solution, is not academic discourse. More often than not, students who volunteer are those who have achieved or are approaching mastery of a math skill. Academic discourse is not about allowing students to show what they know. Rather, discourse involves critical thinking, integration of knowledge, and a synthesis of varying skills. Now let's talk a little bit about what academic discourse in math is. We now understand that academic discourse is not simply having a conversation about a math-related problem. Rather, it involves encouraging students to think like mathematicians, considering a variety of strategies, approaches, solutions, and patterns to use to solve problems. Supporting this level of thinking requires instructors to plan and prepare thoroughly and intentionally for facilitating academic discourse in math. Academic discourse is student-led, collaborative, and inclusive. We learned previously that discourse is not dominated by the instructor. To the contrary, it is led by students as they articulate their understandings in a whole group, peer-to-peer, or peer-to-instructor setting. Academic discourse shifts the instructor's role from the giver of knowledge to a facilitator of thinking. During traditional instruction, instructors provide students with information they need to be able to develop understanding of a skill. However, during academic discourse, students bring the knowledge they have and discuss it in different ways to discover new learning and deepen their understanding of a concept or skill. Considering that academic discourse welcomes experimentation with how students can apply specific knowledge in various mathematical situations, focusing on one skill exposes them to multiple representations of related language, steps, processes, and mathematical formulas that lead to greater internalization of mastery. So, academic discourse in math highlights a specific math skill. Academic discourse is ongoing and active. With strategic planning, academic discourse in math can take place at any point during a lesson where the desired outcome is to encourage students to think critically and synthesize knowledge. Academic discourse is a prioritization of students' mathematical reasoning versus correctness. Rather than assess the discussion for when students are right or wrong, prioritize clarifying, reinforcing, and modifying ideas, knowledge, attitudes, and beliefs about mathematics. Although the instructor does gain important information about the misconceptions students have about a concept and about which students may need additional support, the goal is for students to grow and learn through the discussions they are having about math. Academic discourse is meaningful. Meaningful discourse includes students comparing and contrasting ideas and methods, constructing viable arguments, critiquing each other's reasoning, and helping each other make sense of math concepts. Finally, academic discourse is a required process in learning mathematics. The math standards of all states emphasize the importance of student communication of mathematical ideas, making discourse a required process in learning math. All right, now that we know what academic discourse is and is not in math class, let's look at the formats for discourse, all of which are designed to provide students with practice in mathematical reasoning. First is whole class discourse. In this format, the instructor is in charge to guide learning, and the focus is on students' ideas, pathways, and answers. The whole class communicates and collaborates to make sense of new ideas. Students' confusion is revealed during this discourse, and the instructor can turn misconceptions and errors into teachable moments. Next is small group discourse. The instructor gives students a question or problem to discuss in groups of 3 to 6, then circulates among groups to observe, gather information, and possibly interject when needed. In this format, students control discussions among themselves. Finally is partner talk discourse, in which the instructor asks a question and students respond to a partner or neighbor to put their thoughts into words. You may have also heard this referred to as turn and talk. Partner talk discourse is a great way to engage all students in learning and ensure everyone can contribute to whole class and small group discourse by providing them with the opportunity to practice their contributions, hear ideas from somewhere else, and bring up questions with their partner that they may not be comfortable asking otherwise. This type of discourse also allows instructors to listen in on student conversations to determine which students to highlight during the whole class discussion. Let's take a look into a math classroom where the instructor uses a combination of small group and whole group discourse to allow students to share how they approached a math task.
Okay, now attempt the problem. We have a clear understanding, I believe.
Having whole class discussions of student solution strategies not only builds a community of learners, but allows students to see, hear, and understand multiple approaches to solving the same problems. This in turn helps to build relational understanding, leading to greater student achievement. Presenting students with challenging, open-ended problems, then having them defend their work solutions will result in students learning associated skills and concepts at a deeper level than if they are simply asked to recite factual knowledge or to apply procedures in a mechanical way to problems that have a single correct answer.
I did it the harder way. I kept adding 3 numbers until I got something that equal to 1, and I realized it was 20.
But you still got it, and it's very interesting because that's the way it makes sense in your mind. How many of you would have taken her approach?
I took it.
You took it. Did anybody take it algebraically?
No.
Nobody. Interesting. Okay. Ways you got these problems. Believe it or not, every single group did it a little different. Okay? So I'm going to start over here. Please pick somebody to represent your group and come on up to show me. All right, Chris, now it's you.
I got the answer because it's the same numbers, so I use a variable. It's n plus 1 plus n plus 2 because you're finding 3 different numbers, and that equals 81. So I combine like terms. It's 3n plus 3 equals 81 minus 3 minus 3. It's 3n equals 79 divided by 3 divided by 3. N equals 26. 27 and 28.
Okay, sounds good. Put an 8 right there. Put an 8. Yeah, you got it right. Excellent. Great job. Nice. Okay, so you guys decided to use a variable. You chose n as your variable. Now, that group over there, pick a representative, please. All right, Chris, come on up.
I did it the simple way.
Okay.
I just found three numbers that when you add them together, they give you something that ends with a 1. So then I figured you'd have to be 26, 27, and 28.
Oh, that's extremely interesting.
Yeah, that's good.
Okay, isn't that completely different than what sometimes we think? So it's really important to value everyone else's strategy. He said, he thought, I need to pick the three numbers, just like you said, that would end with a 1 at the end. And then I guess, how did you figure out it was in the 20s?
Well, because 80 divided by 4 is 2. So then, well, 8 divided by 4 is 2.
Okay.
So then they all have to be 2s.
Very nice method, nice. Okay, and then over here, I mean, it's perfect, the way all of you think so differently. Ernesto, would you like to try it out?
I didn't really got the right one. It was mine.
It was Hector. Hector, you want Hector to be the rep for the group? Come on up, Hector.
We did it like, we told that we couldn't use over the 30s because if we use three numbers of 30, it's 90. So it's over the answer. So it should be over, between the 20s and the 30s. So we tried out first 27, 28, and 29. And it gave us, I believe it was 84. So the next few numbers was 26, 27, and 28.
Okay,
And that's the answer.
that's the answer. They did it by trial and error. Okay, 3 different methods, 3 different strategies, we still got the same number.
We've learned a lot so far, so now's a good time for some reflection. What are the benefits of including academic discourse in a math class? Pause the video to jot down your response. The major benefits of including academic discourse in a math class is that it encourages students to think more deeply about math. Students get to work through problems with each other and build off one another's thoughts and ideas. Students build confidence and more readily take academic risks, having had the experience of grappling with complex math problems without the pressure of being correct, but rather with a focus on communicating thought processes to be able to make connections. Math naturally offers multiple ways to get an answer, so engaging in academic discourse in math exposes students to the various problem-solving methods they may not arrive at alone. Let's define the role of the instructor in facilitating effective and meaningful academic discourse. The backbone for discourse relies heavily on the instructor's ability to be a facilitator, someone who guides and leads but does not give and tell. Your role is to engage students in tasks that promote reasoning and problem solving and facilitate discourse that moves them towards shared understanding of mathematics. As you're planning tasks, anticipate how students will respond. Consider the strategies they will use to answer questions. Think through possible misconceptions and plan for how to address them in a way that facilitates students getting to the right understanding without you giving them the answers. As students are working, monitor their actions and conversations. Pay close attention to what you're seeing and hearing while they are working on problems. Which strategies are students using to solve problems? Who understands what the math means and not just the steps? Take notes as you monitor to help you decide who and what will be shared during discourse and in what order. The next 2 practices go hand in hand, selecting and sequencing. Select particular students to present their work. Because the instructor knows the learning goals and the right answers, is aware of possible misconceptions, and has actively monitored as students worked, strategically choosing students to share supports the overall goal of students understanding the current mathematical ideas and strategies. Before initiating the discourse, determine the order in which you will call on students to present their ideas to achieve the lesson goal. The purpose of sequencing students' responses is to make math accessible to all students and to build a storyline. For example, Do you want to sequence students so that they share the strategy used most often to the most novel approach? Or do you want to sequence ideas from concrete to abstract? Or maybe you want students to share errors and incorrect solutions first. You decide on the selected sequence. However, please note that sequencing does not include asking who would like to volunteer to present their solution. The final practice is connecting. The instructor must craft questions to make math visible to students, the types of questions that go beyond clarifying and probing, but that bridge what students know and what they are learning. The goal is to link the student-generated ideas, relationships, and representations to key mathematical ideas. As previously mentioned, facilitating effective and meaningful discourse takes intentional and thoughtful planning and preparation. Few things will be successful in your classroom without you first establishing positive relationships with and amongst your students. Getting to know your students through active relationship building is key to them engaging in effective and meaningful academic discourse, not only in math class, but in all subjects. Take the time to know your students' learning styles, learning differences, unique learning abilities, and approaches to communication that work best. And then use this information to create plans for successful and engaging academic discourse. To prepare for student engagement, instructors should create plans that outline what you want students to discuss from the math lesson, how the discourse will be structured in terms of format and pace, responses to possible misconceptions, and how students will likely respond to a particular mathematical task. Consider as many possible alternative strategies as possible that students may use. One of the most important aspects of academic discourse is its driving questions. Questions must be thought-provoking and accompany higher-order thinking tasks that prompt students to reason and explain. High-level questions should focus on the relationship between ideas and require students to apply their conceptual understanding. Create math anchor charts, word walls, and other visuals that students can quickly and easily access during academic discourse. This promotes the use of academic language, which enriches students' understanding of math concepts. When preparing for academic discourse, be sure to set and model the expectations for what students should be doing and how they are expected to do it. Consider whether students should be sitting or allowed to move throughout the classroom during discourse. If movement is allowed, how are they expected to move? At timed intervals? Independently? Define acceptable voice levels. Determine how, who, when, and under what circumstances students share. Make sure students have the materials needed to engage in academic discourse, including post-it notes, index cards, markers, highlighters, pencils, maybe rulers, calculators, graph paper, etc. Some students require accommodations, and it is mandatory to ensure that accommodations are met. Do not penalize or exclude students for not having materials. Instead, provide them. Finally, review any academic language you expect students to use. Time spent on the review should be minimal and should not turn into a lesson, but should provide ample support for students to fully engage in discourse. Although academic discourse is student-led, the instructor is responsible for initiating discourse and for keeping the conversation going. Pose questions and reiterate the learning goal, objective, or lesson tie-in. To ensure all students can participate, allow students time to think about the learning goals or questions before discussions begin. Determine how you want students to demonstrate their use of think time and include this in your modeling and setting of expectations. Perhaps you will have them jot down their ideas in their notebooks, or you'll have them think silently before sharing their thoughts with a neighbor. Making sure students know what to do during think time prevents students from checking out when they should be leaning in. Call attention to the value of each student's ideas and how they contribute to the class's overall thinking and understanding of concepts. One of the most powerful things about discourse is the collective discussion about a math problem and the different ways it could be approached. Highlighting students' contributions encourages them to share their thinking, even when they're not sure it's quite right. Students will only take the risk of presenting their ideas or errors when a safe classroom environment has been established. Create a space where everyone respects the ideas and errors presented, listens to the discussion, and understands that in this classroom, we critique ideas, not people. This means the instructor models using a non-judgmental tone and allows students to share ideas without interruption. Key to academic discourse is that students learn from each other, building on the knowledge others bring to the academic space. Encourage students to share, even if they aren't sure about their answers, because students can learn from what is correct and what's not correct. When students are right, it reinforces known math concepts and helps students build academic confidence, which allows them to take academic risks. When students have misconceptions, though, they can learn from other students as they hear how others thought through a problem. Asking students why their answers are correct prompts metacognition, which is thinking about their thinking. When students explain how they arrived at a solution and why they use certain steps or methods, their understanding of mathematical concepts is revealed and, if correct, reinforced. This is also when students realize on their own if their thinking is not quite accurate. Students learn to justify their responses and thereby continue to enrich their learning and understanding of math concepts. Now that we've defined the instructor role, we can transition into learning about some strategies for facilitating academic discourse in your math classroom. It is important to note that the strategies shared in this session are not meant to be exhaustive. Rather, they are meant to spark ideas and provide a starting point. By all means, add, edit, and make it yours. What's important is that you commit to engaging in academic discourse in your math classroom. For students to feel comfortable participating in rich academic discourse, instructors must take intentional steps to build a discourse-rich classroom culture. First, build and nurture relational capacity. The level of trust and safety between and among students and instructors is rooted in your work towards building positive relationships with students. Developing those relationships to their maximum means that students can be motivated to immerse themselves and invest fully in their own learning. These relationships mean students can affirm and critique each other's reasoning, welcome and respect disagreements, and continue growing as a community of learners who share learning goals. Building a culture that celebrates mistakes and encourages academic risk-taking creates what we think of as an ideal learning space. Space where students are safe and brave, where inquiry, curiosity, and learning to fail forward are integral to learning, and space where mistakes are welcome and used as learning points. At first, students might be reluctant to participate in math discourse, but as building relationships is prioritized, strategic planning takes place, modeling expectations is consistent, and discourse becomes normalized, students will increasingly give way to the protocols of discourse and use its benefits as a place for experimentation with and discovery of what approaches to problem solving work and do not work. Pointing out math missteps or misconceptions is an important part of their learning journey, and discouraged students should be reminded of their proven ability to overcome challenges in previous lessons. Use opportunities when students persevere through mistakes to celebrate publicly, making the idea of mistakes a welcome feature of learning. Students experience intrinsic satisfaction when there is confidence in their abilities to learn and grow from mistakes. Building a discourse-rich classroom does require that all students work together to solve problems. Whether this be whole group or small group, having students contribute to their learning environment means no opting out. Reluctant learners, English language learners, exceptional learners, all learners work together to problem solve. Eventually, students will look to each other for insight on how to build content, contextual, and procedural knowledge, as well as practice talking, agreeing, and disagreeing in productive ways. In a discourse-rich classroom, all learners work together. So now let's look at a few specific strategies you can use to facilitate academic discourse in your math classroom. The richness of your class discourse will depend on the specific actions you and students take. Most positive discussion-building actions are habits. They are tendencies or practices used regularly once they've been learned. Good discourse skills are not naturally occurring. To reliably have great classroom discussions, it's necessary to instill these skills deliberately. The technique, habits of discussion, involves building a set of habits and norms that cause students to listen actively and talk to rather than past each other, making classroom discussions more efficiently cohesive and connected. There are 4 parts within the technique. Let's start with discussion fundamentals. As simple as it sounds, academic discourse is only impactful if students speak clearly and loudly enough to be heard, and show engagement by looking at whomever is speaking, not every single second, but with consistency. Teach students to speak in a voice that can be heard across the classroom and to track or lock in on the person they're listening to. And an overlooked detail is the practice of expecting students to use each other's names. But this adds clarity when you have a robust discussion going. True discourse requires active listening, and although students tracking the speaker, speaking audibly, and using each other's names are necessary conditions, they don't ensure that listening occurs. Teaching students to listen involves a combination of accountability and inspiration, which is where follow-on and follow-on prompting comes in. This strategy sets the expectation that students are always listening and always ready to participate in discourse. To execute this strategy, call on students randomly and prompt them to respond to something another student has said. The prompt can be directive, such as asking whether a student agrees with what another student said, or the prompt can be non-directive, such as asking a student to add to what another student has said. Once students understand that listening is an expectation no matter who is speaking, and have had the opportunity to practice this strategy, it can become a strong and reliable habit that students use with little to no instructor prompting. Sentence starters are short phrases that facilitate building on someone else's idea. Students reference preceding comments and build off them by saying things like, "I understand why you'd say that, but I'd like to share another example of that." Something that explanation didn't take into account is, "I want to build on what you said." In each of these examples, students begin by framing a relationship between their present comment and the previous one. In doing so, they show respect for previous speakers and weave their comments together with their classmates to form more cohesive discussions. Finally, as students develop their ability to lead discourse with little intervention from the instructor, there will inevitably be times when a student's contribution to the discussion is unintentionally unrelated. The power of academic discourse is developing and expanding ideas through a series of connected comments, and off-topic comments break the connection. We want students to think outside the box. However, in academic discourse, staying focused on a specific topic and maintaining steady, deep reflection on all sides of an idea is often more valuable than creativity. Now, of course, creativity and control can reside in the same space, but sometimes students reach for comments that are way outfield rather than deep, reflective, or analytical. If we don't teach students how to keep their ideas and insights on topic, we can be sure that good discussions will be derailed, sometimes at the expense of true learning. Talk moves are actions instructors or students can take to participate in and encourage academic discourse. As I explain each one in more detail, notice the role of the instructor as facilitator and the students as leaders. The first move is revoice. When students revoice, they repeat another student's answer to emphasize and clarify what the student said and verify whether they have interpreted the student's statements correctly. Asking the student to verify whether their thoughts were revoiced correctly helps clarify or emphasize an idea or major point. Another talk move is repeating. This is when students restate what another student said to demonstrate understanding. This move helps to reiterate important ideas and can be used to slow down the conversation and offer processing time. Instructors can use this move to emphasize an important point and ensure all students heard the student's comments. Asking a student to repeat what another student has said helps the individual student process the information and offers other students a chance to hear the same information in another way, since the comments will be rephrased. This supports diversity in language, especially for English language learners, spurs the use of math terminology and vocabulary, and can highlight significant ideas. The third talk move is reasoning. Once students process a classmate's conjectures, asking students to compare their reasoning to another student's reasoning is where the real magic happens, because students have to analyze the other student's reasoning before making the comparison and creating new connections. This provides an opportunity to do a deep dive into student understanding while students reflect on, analyze, and make sense of the thinking of others. This move also provides an opportunity for students to learn to disagree respectfully. The next talk move is add on. Adding on to another student's thinking or reasoning is a very important move. Like the reason move we just learned, students must make sense of another student's comments to do this successfully. When you use this move, you ask students, would someone like to add to their thinking? This gives students a chance to connect to another student's thinking, which is a higher level thinking skill. We've talked about providing wait time as a step in facilitating academic discourse because it helps students make sense of a discussion and decide which move to make next. But it's also a powerful talk move to teach our students. Once students understand the importance of wait time, they will be understanding of each other when it is needed or requested during small group discussions. Our final talk move is revised thinking. This is the pinnacle of academic discourse. When students revise their own thinking based on the reasoning of someone else, you have got a powerful discussion. We can encourage students to use this strategy by modeling it during class discussions. For this move, students acknowledge their own thinking and articulate how and why it changed after gaining new insight from someone else. Academic language scripts, a very close cousin of sentence starters, helps students reflect on and explain their understanding of math concepts. Using academic language scripts also supports English language learners, students with learning disabilities, or other students who just might need some help to participate more fully in academic discourse. Notice that these types of statements require students to discuss math in ways that are far beyond rote memorization and fact-based responses. Take just a moment to read through each of these examples. During academic discourse, it is helpful to build a communal word bank that includes words students are encouraged to use during the discussion that are not already included on an anchor chart or word wall. Creating this bank together with students gives you the chance to see which words they associate with a math concept or skill and allows you to provide the additional terms that should be used during discourse. Notice that this sample communal word bank includes a variety of words that are operational, such as add and compare, descriptive, such as algorithm, and informational, such as data, formula, digit, equation, and variable. Another strategy for facilitating academic discourse is to have students conduct math interviews. During math interviews, students ask each other a range of questions about math, conversational, academic, and reflective, then work together to deepen their understanding. You can give students a list of math interview questions to help guide their conversations about math concepts and problems. As they talk, you walk around and listen in on their conversations to ensure they are sharing ideas and not just answers. And you can see how well students are able to construct explanations using math language. Let's watch math interviews in action.
Is there a point where you got stuck? And if so, describe specifically what confused you.
Yeah, I got stuck in the beginning because there wasn't really a story to it.
The purpose of the math interview is to really get them using that questioning language. It really strengthens the discourse between the kids.
How to do solve the rest of the problem.
Good morning, everybody. So we're conducting our math interviews today. Before I started, I would get a lot of, well, I don't even know where to start. And now, before they call me over, they've either asked a peer, looked around to check the anchor charts, or they've written down something that they know about the problem. Each of you will be given one task. Either you'll be task A or you'll be task B. First 5 to 7 minutes of class, you work on your problem, I work on mine. We cannot help each other at all. But you don't have to have the right answer to conduct the math interview. So task A, write your partner's name on your paper, on the interview paper. Everyone has the document with the questions all laid out. With task A, you can begin interviewing task B. Now it starts out very scripted. The very first question is, when you read this problem, how did it make you feel? That question is rarely asked in math.
Did you understand what the problem was asking yourself?
And then you get into the nitty-gritty.
How did you solve the rest of the problem? What steps did you take and why?
I had to do line and cosine method.
And so now the kids can enumerate the things that they did.
And then I had to divide.
Once you get all of those out, you get more into the okay, let's get into reflective questions, okay? Have you ever seen a problem like this before?
Is there a point where you guys stuck?
There was a point where I didn't know if the 4 goes over the 36 or the 36 goes over the 4.
Did you give up or did you figure out a way to move forward?
I figured out a way to move forward.
You can go ahead and switch if you have already finished the first interview. after you interview me, if I didn't finish my problem, you can now help me, but only after the interview, because you want the thoughts to come out as pure as possible.
What did that help you know or figure out?
One thing I'm really walking around listening for is, one, are they sharing their ideas?
When they gave me the 3.5, I knew from there to what to multiply.
How did you know what to do? And then obviously I'm looking for that vocabulary of math. And then we could even say, I divided the dependent by the independent. Are you able to articulate yourself using that math language? And also, I'm just looking to see how well they are engaging each other in the interview. It's scripted and it sounds robotic at first, but after you do it so much, kids sort of internalize it. This is how I should ask a question. I shouldn't approach you and say, hey, what's your answer? That has no substance for me if I'm trying to truly learn from you. If I ask you, hey, can you explain to me how you did this? What was step number 1? Why did you do that step? So it's that constant questioning.
Did you give up? I didn't give up because I knew the steps to take, and I took my time to do it and not give up.
So that's the beauty of the math interview.
Academic discourse in math class can generate and promote robust, healthy, and meaningful outcomes. Students get a chance to study and analyze problems in a space where they are not being assessed on how well they are able to meet academic standards, but are instead given the space to think critically as mathematicians and work collaboratively while communicating ideas that include previous knowledge and new concepts. It is necessary to have strategies that maintain and even increase this type of discourse-based engagement. For the final portion of this module, we will discuss promoting habits of discussion during math lessons to keep the momentum of academic discourse and reap the benefits. Let's first talk about normalizing classroom habits. Math discourse will take place throughout the school year and will become easier for you to facilitate and students to lead as it becomes normalized. But what exactly does it mean to normalize a habit? Well, the Oxford Online Dictionary defines normalize as bringing or returning to a normal or standard condition or state. Easier said, it's what you and your students do regularly. And habits are those settled or regular tendencies or practices, especially ones that are hard to give up. Merging these two concepts, we can say normalized habits are things we do all the time that we don't want to give up. Think about that understanding as we discuss the strategies that will help you normalize discussion habits in your math classroom. First, demonstrate active and effective listening. Instructors typically listen with a critical ear to assess the accuracy of information to lead students to correct answers. And while this is still a necessary part of the classroom, academic discourse requires instructors to practice listening as a facilitator of thinking so that students are allowed to communicate ideas independently. Demonstrate effective listening that intentionally seeks to make connections to points previously stated by students. Promote habits of discussion that encourage students to purposefully listen for ideas, solutions, and strategies that connect points. Many math concepts build on each other, and when students have a strong grasp of these concepts, learning new ones is more accessible. So connecting points across lessons and units will help to normalize discussion habits, allowing students to build on prior knowledge and increase understanding of current content. Connecting points encourages students to lean in on the information being shared by others to either agree or disagree, while being able to justify either stance using mathematical facts. Summarize what was heard. When students hear iterations of what they have communicated, it reinforces learning. They hear math terms, steps, processes, functions, and operational rules more than once. Summations also provide students with an opportunity to hear any errors or contradictions to their thinking. Providing a summary of what was heard can be done for individual students as well as the whole group. As students conclude discussions, consistently stack summaries into next steps to build skill, reinforce learning, and create a habit that supports future discourse. Finally, learning should be fun, and celebrations lend to the enjoyment of mastering new skills. Find reasons and ways to celebrate and praise students by recognizing their efforts. This is especially helpful for students who previously struggled. As students receive more positive feedback, they build their resilience for making mistakes and stumbling forward through math learning challenges. Normalizing classroom habits extends to normalizing individual student habits as well. It's not always easy to install these types of norms, but it can be done by assigning students roles, such as these, at the beginning of classroom discussions. This requires proper planning on the part of the instructor and requires that students be provided with many opportunities to practice engaging in discourse. However, when consistently done, students learn an effective method to share their ideas about how to solve math problems and learn to take academic risks. Knowing their ideas may be accepted or challenged, but in ways that lead to increased knowledge and mastery of the content. Take just a moment to look at these different roles that can be assigned to students at the beginning of academic discourse. Let's go back to the curious son from the beginning, who asked the parent how far away the stars were. What would you do to fuel the child's curiosity and keep him interested in learning more? Well, I imagine that you would create a safe space for free thought to exist without being limited by being correct. You would build on the child's ideas and encourage the child to grapple with multiple ways to find the answer. You would facilitate making connections between current knowledge and new information. You would praise the child and give positive feedback when they engage in their own learning, naming the specific ways in which the child takes charge by asking questions, clarifying, making connections, reasoning, etc. You would essentially create a space for academic discourse. We hope you enjoyed this module on facilitating discourse in the math classroom. Thank you, and we look forward to providing continued support for your professional growth at University Instructors.